Morning to everyone. Let us start exercise 10.4. Okay. So now question number 1. Two circles of radii 5 semi and 3 semi intersect at 2 points and distance between their center is 4 semi. Now find the length of the common chord. Okay. So our question is that we have to find the length of common chord, which is PQ. You can see in the figure, PQ is the common chord between these two circles. So we are going to find the length of this PQ. Okay. Now is it clear to everyone? Now the distance of this 2 point, okay, it is 4 semi. So what we will do? We will consider this distance LO dash is equal to x. So this will become 4 minus x because this total distance is 4. It is given in the question. Okay, just make a common figure. It is not exactly per measurement. Okay, so now see what will happen, how we will find the solution of the problem. So two circles, first we have to draw. Two circles intersect 2 points, say P and Q, and PQ is the common chord. You can see in the figure, PQ is the common chord between these two circles. Now, as we have proved that LOLP and O-LP will be 90 degree, okay, because the line drawn from the center on the chord, okay, that is perpendicular to the chord. So O and O dash are the center of the circle. P and LQ will be equal because it will bisect the chord. Now let us consider LO dash as a x and the another part will be 4 minus x. Now use the Pythagoras theorem. What is Pythagoras theorem? Hypotenuse square is equal to the square of sum of the square of the both side. So now our OP square is the hypotenuse. See in the figure, OP square is the hypotenuse, and this PL and OL will be the another two sides. So you can write by using Pythagoras theorem, PL square plus OL square, that is the two another side of the right angle triangle, is equal to OP square. Now place the value that PL square plus 4 minus x square is equal to 5 square. Now expand this as a rule, that is a minus b whole square. Expand it by using the rule a minus b whole square, that is a square means 4 square is 16. 2ab means 2 times ab, 2 for the 8 and b is x, and last term square, that is x square, it will be positive. Negative sign will come here. Okay, that is the expansion as per the rule a minus b whole square. Now take this 16 to the LHS, from LHS to RHS. So 25 minus 16 will be 9, minus 8x will become positive 8x, and x square will as it is. Now take another triangle, that is triangle O dash PL. Okay, so if you take this another triangle, what will happen? The hypotenuse, same rule will be applied there. Okay, so O dash P square is equal to PL square plus O dash L square. So 3 square is equal to PL square plus x square. So PL square is equal to 9 minus x square. So now we have two equations. See, equation 1, PL is the subject of the formula. In equation 2, PL square is also subject of the formula. So LHS of the both equation are same. LHS is the both equation are same. So we can exactly compare it, and when we will compare it, what will happen? X square and x square will cancel each other. 8x is equal to 0, then x is equal to 0. So PL square is equal to 9. So PL will be 3. So LQ will be 3. So 3 plus 3 will be 6. Therefore, the length of the common chord is 6 centimeter, because it will bisect it. Okay, the length will be the double of that value. Is it clear to everyone? So now taking the next sum. If two equal chords of the circle intersect within the circle, prove that the segment of one chord are equal to the corresponding segment of another chord or other chord. So we have two chords, that is AB and CD, that are intersecting at point E. Now what will happen? You see, in a, first of all we have to write everything, because the statement is given. So we have to write, this is our circle, these are our chords, they are intersecting at this point, everything that we have to write. Okay, so AB is equal to CD, then OM perpendicular to AB and ON perpendicular to CD. By the theorem, OM is equal to ON. Okay, so they are chords, they are equal in the length. So the distance from the center of the both chord will be equal. You can see, if AB is equal to CD, we have already a theorem that equal chords, okay, have equal distance from the center. That is our theorem. So AB and CD are equally far from the center. So OM and ON will be the perpendicular bisector, and also OM is equal to ON by the theorem. Now take a two triangle, that is OME and ONE. So OM is equal to ON, OE is OE, that is common side between the triangle, and angle OME is equal to angle ONE because they are 90 degree. So by RHS criteria they are congruent. So OME is congruent to ONE. Now AB is equal to CD, so half of AB is also equal to half of CD. Half of AB is AM and half of CD is DN. So they are equal, and if you add ME and NE both side, it will become, if you add ME and NE both side, it will become AE equal to D. Okay. Now AB minus AE and CD minus C, that will be equal to C. It means that the segment, okay, of the line segment AB and CD, the chords which are intersecting at the common point, the length of that point of intersection and to the circle is equal to the same of the second chord. Okay, it means I want to say that B is equal to C. Okay, nothing, it is, you see, if we have one chord and the second chord, if they are equal, then this part and this part are equal. That we have to prove. It is very easy to prove it. Now the next question, if two equal chords of a circle intersects within the circle, prove that the line joining the point of the intersection to the center makes equal angle with the chord. Okay, in the previous section we have proved that B equal to C, but now we will prove that, I think we will prove that angle 1 is equal to angle 2. means OEA, OE, OEA is equal to OED. So OEA means OEM, I think. Angle 1 and angle 2 are equal, nothing else. Okay. So now, for that we have to prove the triangles are congruent, and after that we can prove it. So AB and CD are two equal chord of the circle with the center O. AB and CD intersect at point E. See here, this is the point of the intersection. This E point is the point of the intersection. So they intersect at point E. Join OE. OM is perpendicular to AB and ON is perpendicular to CD, because we have already, by the theorem, we know that will be the perpendicular bisector. So triangle OME and triangle ONE, the angle OME and ONE will be equal because each angle is 90 degree. So OM is equal to ON because equal chords are equidistant from the center. So OE equal to OE by the RHS criteria, triangle OME and triangle ONE. OME means this triangle and ONE means this triangle is congruent. And if they are congruent, by the simplicity, OEM is equal to OEN, it means OEA is equal to OED, it means angle 1 is equal to angle 2. Okay? So, this is nothing hard, but there is nothing hard inside this question. But just you have to write the proper arguments. Now, see, if a line intersects two concentric circle with the same center is known as concentric circle but different radius. So if you draw the circle like this, same center but different radius, this radius and this radius, it is known as a concentric circle. At ABCD, prove that AB equal to CD. So this segment is equal to this segment. We have to prove it. AB equal to CD. So now suppose a line intersect two concentric circle with center O. ABCD are the point of the intersection. Draw OM perpendicular to BC. BC is the chord of the smaller circle. Now BC is equal to CM because it will divide into two equal parts. And BM is equal to CM. Now in OM perpendicular to AD, AD is the chord of the longer circle or the larger circle. So AM is equal to DM, subtract it, AM minus BM and DM minus CM. That will automatically prove that AB is equal to CD.